And we have mentioned there are seven. There are seven manipulation tools. Some of the tools or some of the figure or some of the, what you call, diagram maybe, either tools, diagram. So it doesn't matter, but either we call they are tools or diagram. And I believe among these seven tools, most of them you have learned in statistics and probability cost, especially for the first one, histogram, stem and leaf plot. The first one is the basic data visualization tools. Check sheet, Pareto chart. Maybe the third one you are not familiar, but I have explained to you. I have shown some example for the Pareto chart to you. Hopefully you know, yeah, when next time you see that chart, you know this is the Pareto chart. And the first one, cause and effect diagram. There's a name for this diagram. It's called Ichikawa fishbone diagram. So for this cause and effect diagram, so normally we will list out the cause and the corresponding effect for a process in the fishbone, okay, in the fishbone figure or in the fishbone diagram. And fifth, detect defect concentration diagram. This one maybe we are not familiar because this defect concentration diagram is specific for quality control. Six, scatter plot diagram. This is to know the correlation for the data we collected. And I think that is the first time. Okay, this is the first time when we learn regression. Then this is the first diagram we have to plot to see whether the relationship, or we say the correlation relationship, exists or not. So just observe from the scatter diagram, or we say scatter plot. And the last one, control chart. Control chart is our main focus in quality control. Although we focus on control chart, but it does not mean that the other tools not important. Okay, so diagram 1 until 7 also important. As QC or QE, we need to use the related or the appropriate diagram to make the data, okay, to make the visualization of data, to make the data to be visualized by, for example, by who? Manager, for example, for customer, maybe. Because you can imagine, we as a QC, yes, we can collect a set of data. Do you want to present the data to your manager, to your customer? It means that the data are all in the numbers. For example, if you are my customer, then I show you, okay, this is my data. Web visitor per day. So I have 10. I just present you this set of data. So if you were customer or you were manager, do you prefer to see this kind of the data in front of you? Of course, no, right? You wouldn't prefer those. You might have many questions. What is this data? Yeah, maybe from the title, you know, web visitor per day. Then day 1 until day 10. Okay, from Sunday to Saturday. Okay, fine. How many visitors for the corresponding days? That's all. Then from this data, maybe you only can guess. First day 563, second day 555. It means that it's a reduction. And then third day reduce again, fourth day reduce again, but fifth day increase around how many? 1, 2, 7, 7, around 70 something, 70 plus visitor, 79 visitor. And then 6th day increase again. So you see, every time when you want to know is a deduction, reduce how many? If it is an increase how many? So if you present the raw data like this, okay, if you just present the raw data like this in front of your manager or in front of your customer, so they need to think twice. They need to think increase how many? Reduce how many? Then how does this set of data behavior? Is it all the curve? I mean the curve always reduce? If not, then how? Is it in a certain time reduce, in a certain time increase, or it's just a reset frustrated? So if you only can present the data like this, as what you see on the screen, so this is not this is not a pass presenter, because you let your customer, you let your manager to think twice. They may not understand. They might have any question want to ask you, right? So the tools I mentioned to you just now, there are 7 tools. So if you can transform your data into either histogram, either in scatter plot, so the raw data not necessarily can be presented in these 7 tools, because these 7 tools have a certain purpose. For example, histogram. What is the purpose we use histogram? We want to show the frequency, right? For example, defection, the number of defection in 1 week. So we can present the data in histogram for the number of defection in a week. So Monday, how many defection are detected? Tuesday, how many? Until Saturday. Maybe Sunday, no others, because Sunday we off. No data maybe. So by showing the histogram, then your manager, your customer may easy to visualize, can easy to see. Oh, okay. So in the histogram, so how's the number of defection of the product look like? If increase, then yes, they can see from their eyes increase and decrease. So we need to really understand the purpose, okay? The purpose why we use, for example, why we use check sheet, when we use Pareto chart, when we want to use cause and effect diagram. We do not go detail, but we have to know. Okay, we have to know their purpose why we need to use them. So before we go to control chart deeply, so just recall some of the information we have discussed for the control chart. So far, what information we have are upper control limit, lower control limit, center line, right? And then sample points, because in the control chart, we will plot the control chart. Now we will plot the sample point into control chart. So it means that the sample point, or we said data point. We also have discussed how to calculate center line, how to calculate upper lower limit, how to calculate lower control limit, upper control limit, lower control limit. So we have discussed how to do the calculation. So today, our main focus is we want to plot the control chart. So there are two, okay, there are two ways. Either we plot the control chart by drawing, by menu. I mean we draw the control chart. We draw the control chart by hand menu. Second, we plot the control chart by using any computer software or any computer tools. So the most easier one is draw the control chart by hand. If we are given several samples, okay, several samples, because when we draw the control chart, we do not consider only one sample. We need to consider at least 2 or 3 samples. In one samples, how many? Yeah, maybe I should not use sample. I should say, yeah. From our understanding, when we say sample, and then in one sample, how many points, right? But actually, they will make us a little bit confused when we go further. Because in quality control, other than sample, we also have another terms called observations. Later, I will explain detail about these two things. Sample, number of sample, number of observation. Okay, these two things I will explain more detail in the following slide. So just now I have mentioned to you, yes, draw the control chart by hand, by menu. Very simple. So we just use a calculator, then we can calculate. But just imagine if we have 5 samples. No, we have 5 observations. Okay? In our understanding, we say sample. Sample 1, sample 2, sample 3, sample 4, let's say. So 4 samples. Each sample they say they are 10 points. So sample 1, 10 point or 10, 11. Sample 2, 10 point. Sample 3, 10 point. Sample 4, 10 point. Okay, so we can calculate sample 1, what is the sample mean? Sample mean 1, sample mean 2, sample mean 3, sample mean 4. Fine. So there are 4 means. So mean 1, mean 2, mean 3, mean 4. What is the mean of this? What is the means of these 4 means? We still can calculate by using calculator, by using menu. It's not a problem. But just imagine in the real situation, in one sample there are 100. No, 100 is too many. Let's say 20, 20. 20, 20, so there are 4. So first group, in the first group there are 4. No, there are 20. There are 20 data, there are 20 values or 20 points. Second group, another 20. Third group, 20. Fourth group, 20. So they are around 80. Are you able to calculate the mean for each group and get the mean for these 4 means value by hand? Still okay, right? Just spending more time. But just imagine if we have 100, one group 100, second group another 100. It's impossible, right? Using menu. Then we have to use computer to help us. So when we mention the computer, when we use computer to plot the control chart, so actually in the market there are so many computer software or computer tools can help us. The most easier one is Microsoft Excel. We can use Microsoft Excel to plot the control chart. Other than Microsoft Excel, we also can use Minitab, SPSS, MATLAB, Python, Statistica, Julia, R. You see, I have mentioned you so many statistical tools, mathematical and statistical software. How many software you have learned? Maybe you can type in the chat room which software you know, or which software you have learned in data analysis courses. You have taken data analysis course, right? Oh, only these two, SPSS, Minitab. How about Excel? Oh. How about Maple? How about R? No, right? Python, yeah. Some of you know how to use Python to plot the contour chart. I will discuss with you how to use Microsoft Excel to plot the contour chart. Maybe we can explore for others software. Yeah, I suddenly think of one issue. This issue is quite interesting, especially when I observe your seniors FYP. Why? Because what I observe from your seniors FYP study, in their proposal they wrote, okay, they want to study a certain topic, and then they will use Minitab, Excel, Python, for example. Okay, this is just for example. So as examiner, I was so curious. Why you use three type of computer software? So your senior said, I use Excel to do the data analysis. I use Python to do the calculation. I use I use Maple to plot graph. You see, your senior category or divide the purpose of software. Excel, yes, we know Excel is quite strength, quite useful, quite powerful for the data analysis. We can key in the data, and then they use Python or maybe MATLAB. They said want to use MATLAB or Maple for MATLAB, Python for calculation. They will write the computer command to do the calculation, and then they use Maple to plot the figure or graph. So we understand Maple is quite good, quite useful, or the diagram or the figure given by Maple is quite pretty nice to see compared to MATLAB or compared to other software. So they try to highlight the features of the software. But as a researcher, we might think that why you use three software? Is it Excel only can do the data analysis? No other software can do. Or is it Maple only can be used to plot the graph? No other software can use. So it come up with a equation. I asked the senior, you only know their features, then you cannot find a software to do these three tasks. Shall we find or shall we learn three software only for the respective tasks? Or is it possible we can find one software but we can do three tasks? So the same thing happen as QC or QE. When manager asks you to present something, for example, your company launched a new product. So manager want to know how about the quality characteristic, how about the quality improvement, how about the quality performance. Okay, you plot the control chart using Excel. Because why you use Excel? Because you have learned how to use Excel to plot the control chart, And then You want to show the figure. Okay, you want to show the data in, let's say, in histogram. Then you use, let's say, you use Minitab. Then you use Python to calculate the sample mean, to calculate the variance. So you can imagine if you was a manager, okay, if you was a manager, I did these three things in front of you, you might ask me, why you use three tools just want to do the presentation? Why not you use one software and then you do all the tasks? So you understand what I mean? So in the following discussion, I will discuss with you how to plot the control chart, do the calculation. So actually, do you know that we can use Excel not only for data analysis, we also can use Excel for solving the differential equation, for numerical method, for matrix calculation. You know this thing? Yeah, I think many of you know, right? You just keep silent, pretend to know. Okay, but it's not a problem. Yeah, if you know, then I no need to spend the time to explain. We can move quickly. Okay. Yeah, before we want to plot the control chart, so I would like to discuss with you certain calculation. How to calculate the sample mean? How to calculate the sample standard deviation? How to get the sigma label? How to know the sample size and time interval? Sample mean? Yeah, we do some revision. Okay, so this one we have complete. We have discussed yesterday. So for today's discussion, actually I want to show you how to calculate the sample mean. But before that, because I already showed you this slide in front of you, so just simply let you to know, for this variable control chart, in our discussion, we will discuss three pair. Okay, three pair of control chart, X bar and R chart, X bar and S control chart, two pair. One more pair. What is the next pair? Suddenly forget. How come can forget? The third pair is IMR. What does mean IMR? Can you see from this? Here, 6.4, individual measurements. Okay, I repeat. In this chapter, control chart, variable control chart, so we will discuss three pair of control chart, X bar and R chart, X bar and S chart, and individual measurements control chart. So there are three pair. Okay, come back to what I want to mention to you just now, how to calculate the sample mean. Yeah, you can see on the screen, this is the formula we use to calculate the sample mean. So X1, X2, X3 is a sample of size n. Is a sample of size n. So it means that X1 a sample, X2 a sample. Right? Is it like this? X1 sample of size n, a sample of size n. So each of the sample how to say, it's a sample of size n. Yeah. This is just words. So let us try to understand this word. A sample of size n, x1, x2, xn. So it means that this is a sample. Okay, this is one sample. So in this sample, they are endpoints. So x1 is 0.1, x2 0.2 until xn. So they are endpoints in this sample, one sample. And then the average, so we have x bar. So only one x bar. So how to calculate this sample mean? So sum out x1 plus x2 plus x3 plus until xn. Divide sample of size, sample size, and they are divide by the how many? Divide by the number of point in a sample. So they are n points. So sum of the sample point divided by number of sample point. So we get sample mean, or we say average of the sample. So we use a notation x bar to represent this sample mean. You know this thing, right? We just do the derivation to solid, okay, to solid our understanding. X bar is normally distributed with mean, mu, and standard deviation, sigma x bar, equal to sigma over square root of n. We know mean given by mu, so this is the population mean. And then sigma is called population standard deviation. But because we do the sampling, and from central limit theorem, x bar is equal to mu. Sample mean is equal to population mean with the condition if sample size n is large enough. And then sigma x bar is the standard deviation. So this sample standard deviation we should consider, or we should use population standard deviation divided by square root of n. Or we can consider the variance, sample variance. So we have sigma x bar square equal to sigma square over n, sample size n. So we need these two information, mean and sample standard deviation. And then we have equation 6.1. Equation 6.1, I think this equation I have mentioned to you in the last few classes. Mu. So we can join them together. Okay, we can use plus minus. So mu plus minus z alpha over 2 times sigma x bar. So you can rewrite them into two equations, one for plus, one for minus. But from our previous discussion, we know we can use this equation 6.1 to calculate the control limits. Plus for upper control limit, minus for lower control limit. And then in our previous discussion, we've mentioned about 2 sigma, 3 sigma level. So these 2 sigma, 3 sigma level are represented by Z alpha over 2. So start from today, the control chart we want to plot may not necessarily 3 sigma level, will be depend on Z scores value, or we said will depend on different sigma level, Z alpha over 2. So will depend on the value of alpha. Different alpha will give us different sigma level, or different alpha value will give us different Z score value, Z value. And I think this thing you know. Unknown, if we don't know mu, we don't know sigma, what to do. So we have learned this thing in sampling. I think we need to highlight a certain. 1, 2, 3, the third line. This estimate should usually be based on at least 20 to 20 samples. Okay, we need to highlight this sentence, 20 and 25 samples. So it means that we have 20 to 25 points, sample points, members, or data point. And then the following sentence, this one want to make sure you really understand, because sometimes we confuse. Suppose that n samples are or a variable, each containing n observation on the quality characteristic. So we have n sample, we have n observation. Typically, n will be small, often either 4, 5, or 6. This small sample size usually result from the construction of rational subgroup. So n is called observation. M refer to samples. How many samples? So there are n samples. Then how many observation? 4, 5, or 6 normally. Okay, 4, 5, or 6. So we can use equation 6.2 to do the calculation. Notice that 6.2, you see, similar to equation 6.1. Do you notice that? Oh, sorry, not 6.1. Equation before 6.1, x bar equal to. So you see this formula, x1 plus x2 until xn divided by n. But in equation 6.2, you see x bar 1 plus x bar 2 plus until x bar n over n. Now, if you still remember, I have mentioned to you mean of the mean. So the mean of the mean refer to x bar bar in equation 6.2. So let x1 bar, x2 bar, xn bar be the average of each sample. Okay, each sample. So sum out all of the mean value divided by the number of mean value, then we get x bar bar. So we call this is center line of the x bar chart. So next time I will mention this x bar bar as mean of the mean, or I just simply said, okay, x bar bar. So hopefully you understand, you know this is x bar bar. How to calculate x bar bar? Using the formula to calculate the mean. Okay, come back here. So now we know how to calculate the sample mean. We know how to calculate the sample standard deviation. Refer to alpha's value. We can calculate the sigma level. And then from the sample we collected, we know what is the sample size. And then from time interval, this time interval refer to the period we do the sampling, as we discussed yesterday. Then we can do the calculation, calculate upper control limit, center line, lower control limit. If your Excel is ready with you, then you can try to key in the formula. Okay, you can try to practice so that you know how to use Excel to do this simple calculation. Okay, to calculate upper control limit, I'm not sure whether you can see clearly because I put them in color. Upper control limit, so F5. Where is S5? Yeah, F5 plus C 7 times C5. Enter. Central limit. So this is the features of Excel. If we want to use Excel to do the calculation, first, if you want to read the value, type equal either you click on it, click on the value we want to refer, and then enter. Or type equal. So you see, every time we need to type, we start by typing equal on the Excel, on the cell of worksheet. So every time we type equal. So if you don't want to plot, you don't want to click on it, you can type the position. Center line is located at C3, right? Column C and line 3. So we can just simply type C equal and then following by C3. Okay. So this is to read the value. Can you follow?
Yes.
Okay, good. Okay, just now I mentioned to you how to read the value. Now we want to do the calculation. So to do the calculation, actually we want to read the value and put the value into the formula. For example, upper control limit. So this is what I mentioned to you. Read the value first. So to calculate the upper control limit, we need to know center line, we need to know sigma level, we need to know sample standard deviation. So actually we will read these three values and put them in formula form. So F5 center line, you can type equal and then and then click on F5 plus C3, C7. C7 refer to sigma level. So you type plus and then you click on C7 and then press star and then click on C5 and then enter. So read the value and put the value in the formula to calculate the upper control limit. If you don't want to click, you can do as what I did for you just now. Just typing equal F5 plus C3 times C5. Okay, just type the position. Okay, type the position of the value located. Okay, you can try for lower control limit. So it's equal F5 minus C7 times C5. And then for this probability that any point exists to control limit, so just use the formula 1 minus normal distribution, normal standard distribution. Okay, norms this. So this command norms DIST. This is stand for normal standard distribution. We know normal standard distribution refer to the Z value. So Z value, from our discussion, we know Z value is called sigma level. So our sigma level is at C7. So from our discussion, how to calculate this sigma level. So we take 1 minus, we take 1 minus sigma level. No, we take 1 minus probability, right? This is probability, right? One minus what? How to read that meaning? Probability, the point located at the right hand side of critical point, or the probability x greater than 3.09, or the probability I mentioned about normal standard distribution 3.09. Okay, I repeat, normal standard distribution 3.09. So we will read this value from the statistical table. So this is the probability x greater than 3.09. So from the statistical table, the value is 0.01. Yeah, if you still remember, 3.09. Yeah, 0.01, right? What happened? Oh, okay. Oh, normal standard distribution. After we take 1 minus, this is only one side. But for the control limit, we might consider two-sided. So 1 minus and then multiply by 2. So it's 0.0020. And then these two items, we have discussed these two items yesterday. So how to calculate? 1 over P. Average run range, 1 over P. P is 0.002. So 1 over 0.002. 500. So it means that we will do the sampling. We will consider until 500 samples. Or is it confused if I say sample? Yeah, we have to be careful to use the term in quality control because sometimes group, maybe we have feel confused. If I said observation or group, maybe we can say group, 500 group. So it means that this ARL equal to 500. It means that we will consider or we will take 500 subgroups before an out of control signal happen. And then average time to signal. So it depends if the time interval is 1 hour. So when is the out of control signal happen? When happen? When does it happen? 500 hours. Okay, 500 hours. You will detect the out of control signal. So these are two items we have discussed yesterday. So I don't know how many of you already understand, or maybe many of you know how to interpret. I always mention to you not only to do the calculation, but make sure you can do interpretation. If we just can calculate, let's say ARL, okay, 500, then what does it mean? Because as a QC or QE, we cannot do the interpretation. It means that we cannot perform our work well. Just imagine you are a manager. Then I present in front of you. I said, okay, average run rate is 500. No more. Full stop. If manager or if customer not really understand, hey, what is this ARL? Can you explain? ARL. You only can say like this, right? You cannot explain further. So that's why I say, as QC or QE, we need to explain a special term in more detail so that customer or manager, they can understand. Okay, so you can try to do some calculation as I present to you or as I demo to you. This is how to use Excel to do the calculation. I prefer we use one software to do all the things. Okay, what I mean here is, yeah, we use Excel. So use Excel to do calculation, use Excel to plot the control chart, use Excel to what? Yeah, of course, Excel cannot. If you want to type, for example, you want to type remark, or you want to type the what I call reminder, or you want to type the statement in Excel also can, right? You just need to know how to type. If you don't know how to type, you will find it all the sentence will put together, will be crowded together. They are not in one line, or they are not in one sentence. They are all put in one column. Not nice, right? People may not understand.
Doctor, I have a question.
Yes, you can ask.
Can you show the formulas used for all the numbers here?
Oh,
In Excel, there's like a thing that you can do where all the numbers will become show in formula form.
you mean you want to know the formula?
Like used for this Excel.
Okay, with formula.
It's in formula tab, and there should be something called show formula at a bit of the right. This one. This one. So you will show all the formula that you use for all the number. Oh, but maybe you can minimize.
Okay. Yeah, I want to mention to you, yellow color is user input. User key in the value, no calculation. But green color, we set the command. So Excel do the calculation. Yeah, if you want to refer, yes, you can see the formula here. So you can just type the formula, or you just type the command. Then next time Excel will do the calculation for you.
Okay, thank you, doctor.
Okay. For those, maybe you think that, so right now I'm not so convenient. So yeah, you can screenshot. Okay, you can make the screenshot, and then after the class, and you find the convenient time, and then you can try to practice. This is to use Excel to do the calculation. Yeah, simple calculation, right? It is not challenge compared to write the computer code in MATLAB or in Python. It's very simple, straightforward, the formula. The formula like the equation you write on the paper. If got time, maybe we can explore how to use MATLAB. Yeah, if we can use MATLAB, I think it's much more easier. And then how to plot the control chart? Refer to the value we have. So we know upper control limit, we know center line, we know lower control limit. So actually, once we know these three items, UCL, CL, LCL, is enough for us to plot a control chart like this, empty control chart, no other point. So this is we call the initial stage. Okay, before we can plot a complete control chart. We just build out the framework for control chart. So there are three lines. The first one, upper, middle, center. The last one, lower. Once we can get this empty, then the next step is just to plot the point into the control chart. Okay, any other question? Okay, if no question, I think we can go further. I think we go back to the slide first. We discuss X bar and R chart, then we try to plot the control. We try to plot X bar and control chart. Okay, so we have just now we have discussed until 6.2, equation 6.2. So this is the formula to calculate X bar. I want to mention you X bar. Yeah, X bar is called what? Center line, isn't it? X bar is called center line. So to plot the X bar control chart, so we need to know how to plot how to calculate the upper and lower control limit by using X bar. So from our discussion, yeah, refer to 6.1. the formula the same, but I mean, we will use 6.1 to calculate upper and lower control limit. The formula the same, but the value will be changed, a little bit changes on the formula. No, I should not say a changes. I should say we use 6.1, equation 6.1, the formula. We use the formula in equation 6.1 to calculate control limit. But the value will be different. Let's see, what does it mean, difference? We go to, this one. Equation 6.4. Please compare equation 6.4 and equation 6.2. Just now I have mentioned they are different, right? So it's mistake. I should not say difference, because equation 6.1 and equation 6.4, actually they are equivalent. Okay, they are equivalent. So you look at equation 6.4, x bar bar plus a2 r bar, x bar minus a2 r bar. So you can notice that this equation, if I join them together, so it becomes only one equation. X bar bar equal to plus minus a2 r bar. So it is similar to equation 6.1, isn't it? Okay. If we join together, so we have mu plus minus z alpha over 2 sigma x bar remain only one. It means we can combine two equations in 6.1 into one equation. So the same thing for equation 6.4. And you can see the appearance, they have the same format. They are same format, or we said they have the same form. Plus minus, x bar bar plus minus. But some of you might ask, how to get A2? How to calculate A2 or how to calculate R bar? So we go back to, before we can calculate R bar, so we have X bar, we have R bar. Just now we have X bar bar. But now, refer to equation 6.4, there is a term R bar. So before we can calculate the value of R bar, then we need to know what is R. So here, R stands for range of the sample. What does it mean, range? Range is the difference between the largest and the smallest observations. Okay, I repeat, or maybe you can highlight. It is at the last sentence on the screen, you see. The range of the sample is the difference between the largest and the smallest observation, given by R equal to X max minus X min. So this is the R value, range. And then for each R1, R2, we can calculate the average range. And each R refer to a range of the M samples. So we have M sample, so we have M R value, R1, R2 until Rm. So refer to this M R's value, we can calculate the average of range given by R bar, which is 6.3, equation 6.3. Okay, so I think equation 6.4 is clear. We know how to calculate R bar. We know how to calculate X bar, we know how to calculate R bar. Then remain one question. What is A2? Okay. I should turn on the ebook. Yeah, if you can turn on the ebook, you go to the appendix. Appendix table 6. Yeah, table 6. Table Table 5. Table 5. Table 5. Where is table 6? Table 6, this one. Yeah, you can go to page 70, 720, 720. So refer to this table. This is Appendix 6, factors for constructing variable control chart. So there are 1, 2, 3, there are three groups, or there are three categories. Chart for averages, chart for standard deviation, chart for ranges. We want to plot we want to calculate control limit for the X bar chart. So what is A2? Factors for control limit, chart for average, factor for control limit. So you can see A2 here, no others. So you just refer to the first category, chart for averages, and then refer to factor for control limit, then you find A2. There are three items, A, A2, A3. Okay, there are three items. Now, what is the observation in samples? What is n's value? So it depends, right? It depends. Start from n equal to 2 until n equal to 25. And then for n greater than 25, we cannot read the value. We cannot read A2's value from the table. What can we do is use the formula to do the calculation. Okay, this is the formula. A equal to A3 equal to, where we do not see A, we do not see what is A2's formula here. A3, C4, B3, B4, B5, B6, no A2. This is for table 7. Normal tolerant limit. So we don't refer to this. We only refer to this table. Okay, Appendix 6. And then for R chart, why in equation 6.5 you see R chart? Why the R chart? Why in the R chart the center line? No, the control limit. Why the control limit in R chart only have one term, D4 times R bar? But in 6.4, control limit for X bar chart, we have X bar bar and then plus A2 R bar. But in control limit for the R chart, we only have D4 R4 R bar. Why we do not put R bar plus something like R bar plus? Why we do not have the same structure or same pattern compared to 6.4? Yeah, so we can answer this question in the following explanation. But before that, what is D3 and D4? Again, refer to this table, Appendix 6, D3 and D4. Okay, the third category, factors for control limit. No, chart for ranges, factors for control limit. So you can see there are D1, capital D1, D2, D3, and D4. So for R chart, we will refer to D3 and D4 for the respective n's values. And if you have a look in this table, all are positive value, no negative value. Okay, return back here. Just now we stopped at here, right? 6.3, and then 6.4, 6.5. Then, can we calculate sample standard deviation for range? So we take R bar divided by D2. Again, what is D2? We can read the D2 from here. chart for standard deviation, factors for center line, D2. You see, small D2. So this small D2, there are so many D2's value. So we just select the corresponding n's value to pick the appropriate D2's value. So now you see the calculation become much more easier because certain value we read from the table. Okay, now we use x bar bar as estimator of mu, and then r bar divided by d2 as sample standard deviation, or we say estimator of sigma, and then the parameter of x bar chart. Okay, when we mention the parameter of x bar chart, so these parameters are referred to UCL, centerline, LCL. So not necessarily in x bar chart, in R chart, in S chart. Either we set the parameter of R chart, the parameter of S chart, or we can set the parameter of control chart. So this word parameter refer to these three items: UCL, centerline, LCL. Okay, so now we can put them in order. So x bar bar plus minus refer to 6.4, you see? This is 6.4. But now we can substitute 3 over d2. Okay, 3 over d2 square root of n. So this one actually still the same for 3 sigma level. 3 sigma level control limit. Yeah, you refer to here. Okay, refer to this. And then just recall the control limit, how to calculate the control limit. So x bar bar plus sigma level time. Yeah, recall the more common. Okay, recall the common formula we use to calculate the control limit. If you still remember, we have a common, right? Mu W plus L multiplied sigma W. So in this situation, our mu W is x bar bar. Our sigma W is R bar divided by D2. Okay, R bar by D2. R bar divided by D2. 3, number 3 refer to 3 sigma level. Then why we have extra sigma, no sigma, square root of n. So if you put R bar divided by D2, where does square root of n come from? Is it from here? Okay, from here. Okay, from here we have square root of n. But for this formula, 6.7. Maybe some of you still blur. Before we can write 6.7, actually we can write the formula in the form we familiar, and then we simplify it and then rewrite it into 6.7. And then you understand. So you need to write down something. Okay, let's see whether I can write something on the screen. Is it text comment? Okay, wait for a moment. Maybe I can. Okay. Yeah. You also can have a try. Okay, you can also have a try before I show you the formula. Before we can get equation 6.7. Yeah, sigma head. Okay, suppose in this way, right? I'm not sure you can see. Yeah, this is the formula, right? Simple formula. Or we said 3 sigma control limit. Then we substitute. Okay, we substitute or we replace. We replace the term. So x bar become x bar. Okay, and then sigma head. Yeah, I think I put in the bracket. So sigma head equal to what? Okay, this is the sigma head. R divided by E2. Okay, it become like this. Sigma head equal to R over D2. Then how about square root of n? Okay, refer to 6.1. Suddenly blank. How to get square root of n? Where does the term square root of n? Before we can get 6.7. You see, I lost something. No. Okay, fine. Yeah, I might have lost something. Okay, wait for a moment. I might have lost certain terms.